Hi, I'm Olivia, everyone's favorite math teacher, and welcome to the Calculus series. In these videos, we're going to be going through the entire AP Calculus curriculum, although I do want to warn you that these videos are not a replacement for the classes. They're meant to supplement any of the course material. So use these videos in addition to either your self-study or your live classes. Also, these first 4 videos are going to be a review of functions, a topic that you typically cover in your Algebra 1 and Algebra 2 classes. We're going to be covering them at a relatively high level and pretty quickly. So if you find this material on the first 4 videos to be confusing or difficult, I highly suggest to pause before you continue with the material, go back, review some Algebra 1 or Algebra 2 material, or jump into the comments and ask some questions to make sure that you're ready before you begin the real calculus material that will start around video 5. So let's start with our definition of a function. And to do that, we're actually going to begin with a set, or in this case, 2 sets. Now, a set is simply a collection of stuff, and we call the things in a set the elements. There are rules and things that you can do with sets. We're not going to worry about those for now. That gets covered later. For our purposes, a set is a collection of stuff. The things in a set are called the elements. Okay? And a function is a rule that assigns to each element in one set, A, exactly one element from the other set, B. Now, that might not be the definition you've heard before, but this definition is a very concise way to tell you exactly what's happening. And what this definition is telling us is that every single thing in our first set, our set A, everything there, is being assigned to something in set B, and that it is only being assigned to one thing in set B. But what's important here is that for our basic function, it's not telling us that everything in set B is being assigned to something in set A, just that everything in A gets assigned to something in B. That's pretty important. And then the other thing that's important here is also that everything in A doesn't have to be unique into B. Everything here has to only point to one thing in B, but you could actually have 2 things in A point to the same one thing in B. And again, you've probably seen this before, but basically what we're saying is this kind of a setup is fine. Okay? You could also have a situation where if we had, say, an x3, it could point here, and that would be fine. However, you could not have a situation where x1 pointed to both f of x1 and f of x2. That would make this no longer a function, because something in A is assigned to more than exactly one element in B. So that would break our rule. Okay? So let's go and erase that for now. Okay. We'll talk a little bit more about this in a second. So a couple of other things to note about this, vocabulary-wise, things you're going to hear a bunch, is that set A, our input set, is also called the domain of the function. So all of the things that we go into the function, our inputs, our independent variables, those things are the domain of the function. So often you'll hear this as the x values for the function are the domain, and then all of the things that come out of the function, the outputs, the dependent variables, that is the range of the function. The other term you'll sometimes hear is called the codomain. More typically here in the United States and North America, we use range, but codomain is another term that you'll often hear. Okay? So again, Set A would be called the domain. Set B would be called the range of the function. And then notation-wise, we would say that the elements in A would be x, or whatever your variable is. It could be t, it could be s. X is just the most common. And then your range would be your f of x. And again, it does not have to be f or x. For example, you could have A and Q. So you could have, for example, Q of A. That's perfectly acceptable. Our variable would be A. Our function would be Q. This is simply function notation. Okay? Thing on the outside is the function. Thing in the parentheses is the variable. Now, if it helps you to think about this, another way that this is often thought about when we think about functions is the way the word function gets used when we talk about machines, or think about like in the kitchen. Think about appliances. When we say that things work, we say they are functioning. So the easy example is, think about a toaster. When a toaster is working, when it is functioning, what happens? You put bread into your function. So the domain would be types of bread, things you put in a toaster. So bread, Pop-Tarts, things like that. You put it in a toaster, you push the button down, it does whatever the function does, it does whatever the toaster is supposed to do, and out pops toast, or out pops a heated Pop-Tart. That means the toaster is functioning. It's done what it's supposed to do. You know what goes in, you know what comes out. Meets expectations. When it is not functioning, you put bread in and maybe it doesn't cook long enough. So you get, instead of toast, you get warm bread. Or it cooks too long and instead of toast, you get charcoal. The toaster is not functioning. You don't know what will come out. That would have been the example where we put bread in, x1, and we didn't know, are we getting toast or charcoal? We don't know the output. Or another way to think about it is, a function is like a vending machine. You put money in, you click buttons, you get out the thing you asked for. Something that is not a function would be a gotcha machine. You put money in, you turn the dial, it spits something out, and it will be within a range of expectations, but you're not going to know what it is until you open the little ball and see, oh, you got whatever it is that was inside the little ball. So that's an example of not a function. Still perfectly acceptable, but not a function. Mathematically, an example of that would be when, for example, we take the square root of a variable and we get plus minus. We have two options that can come out. We don't know. It could be the plus, it could be the minus. We have to go back and check. Another example is that when we're working with circle equations, you can have multiple answers that come out because you could be in any of the four quadrants and still be within an acceptable value because of the nature of the unit circle when we're working with trigonometry. So those are all examples of things that are perfectly acceptable equations, but they don't really work as normal functions because you have to go back and you have to do some kind of a check. Okay? Next, we're going to talk about how we represent functions. So here we have our 4 different ways of representing a function. Verbally, with words. Numerically, typically with related data tables. Visually, usually with a graph or a diagram of some kind. And of course, algebraically, with symbolic notation or an equation or function rule of some kind. Now, in this situation, this is a kinematics problem that you might find in a basic physics class. So here we're talking about firing a cannon from the top of a cliff. We've got an initial velocity, we've got a height. So we're relating a horizontal motion and a vertical motion, basic kinematics stuff. And effectively we're saying, when is that cannonball going to splash down, where we're ignoring everything except for effectively gravity on this cannonball. So we combine a couple of equations, and boom, we get our function rule. I hope you found this video helpful. If you have any questions, feel free to ask in the comments or join the Discord. In the next video, we're going to be talking about types of functions. I'll see you then. Bye.